Okay guys, welcome back, and today let's answer this given problem. So we have here the circle parts and its line segments. Well, we have here the given problem, which is OD is perpendicular to CE. So in the figure, what is the line OD? So this one is the line OD, and line OD is the radius of a circle because it is determined by the point of a circle and the center point of a circle. So that is a radius, and it says that is perpendicular to line CE. So this is the line CE. Okay, and obviously the line CE is the chord of the circle because it determines the points of a circle, right? Now, the question here is we have to determine the measure length of OX. Okay, let's read first the other givens. So measurement length of OE is 5 inches. So where is OE there? Okay, OE. So this one, OE is equal to 5 inches. So let's indicate its values. And measurement of the length CE, so where is CE? This one is equal to 8 inches. That is 8 inches. So CE, that is 8 inches. Next is the question. The question is measurement of OX. So where is OX? This one and up to this point. So we have to find the length measurement of this line segment, and that is our problem. Well, to answer, let's read first a theorem that related to this figure. Well, I have here the book and the stated theorem. So theorem 3-1. So it's about the radius that is perpendicular to a chord. So our problem looks like this, right? So it's stated here that if the radius is perpendicular to a chord, then it's bisect the chord. Now, question, why I am reading this theorem? Because it will help us to solve our problem. So again, I'll repeat. If the radius is perpendicular to a chord, then it's bisect the chord. Okay, when you say bisect, the radius is divided the chord into equal part. Okay, now if you relate this figure to the theorem that we read a while ago, okay, stated there that this radius is bisected to this chord. OD is bisected CE. So meaning to say CE is divided into equal part. So if CE is equal to 8, meaning to say EX and CE, EX is equal to 4 and CX is equal to 4 also, because according to the theorem, it is bisected by the OD because it's perpendicular, right? It's given there. OD is perpendicular, so meaning to say it's bisected one. Now our next problem is, our main problem is to determine the value of OX. Okay, how to determine that one? So we all know in the given that this is perpendicular. Now if it is perpendicular, meaning to say we form right triangle. Okay, to determine that one, all you have to do is to use Pythagorean theorem. So we have now the value of 2 sides, 4 for the leg and 5 for the hypotenuse. This is the hypotenuse because this is the opposite of our right angle. Now let's solve the side OX. Okay, so we can use Pythagorean theorem because the triangle that we form is a right triangle. Okay, now let's determine the value. So we all know that in the equation, C is the hypotenuse and A and B are the 2 legs. So here the given is the hypotenuse, which is 5. So just substitute that one. 5 to the second power equals A is the problem plus B is equal to 4 inches. Okay, just simply do the math. And 5 to the second power, that is 25, equals A squared plus 4 to the second power is 16. Then apply some properties of real number. Okay, you can move 16 to the left side of the equation, so it will turn to 25 from positive to negative. That is addition property of equality. Then just bring down A squared. 25 minus 16. Okay, so that is 9. A squared. Okay, let's move first. Okay, then after that one, you can do extracting the root of the number. So again, we will not going to use the positive and negative root because we are talking about the length. So there is no negative. Mean to say negative value here is not useful. Okay, so root of 9, that is 3. And this one cancels. So therefore, A is equal to 3. So mean to say our length OX is equal to 3 inches. So this is 3. Okay, again, that's all for this time. Hope you learned something.